Happy Sunday! I asked ChatGPT for a nice question about powers, and here I got it. A really nice question, and I am able to solve this, to simplify the question, with only these 8 rules of exponents. Can you do it? Please pause the video and try this yourself. To simplify an expression like this, you can work from outside and in, and then you try to get rid of the exponent here. Or you can work from inside and out. And I will start inside. I will start with the bases and try to write all these bases here in factors of smaller numbers, in prime factors. Okay, and I show you why in just a moment. But I take out these numbers and factorize all of them. I start with number 12 and I do it like this. It equals 2 times 6. 6 equals 2 times 3. So 12 equals 2 raised by 2 and times 3. The prime factors are 2 and 2 and 3. So instead of 12, I put this expression here in this place. And now I do the same with the other bases. The next step is to rewrite the whole expression and substitute these bases with the prime factors. It is very important to write these extra parentheses around the bases because the whole base is raised by 2 in this example and minus 3 here and so on. So write the extra parentheses around the bases. The next thing I focus on are the exponents here, and we can move these exponents into the bases by using rule number 5 from right to left. If you have an exponent outside parentheses, then we can move it inside each factor if we have a multiplication inside the parentheses. So this number 2, we can move it inside here, and we can move this one inside, this one inside, this one inside, and this one too inside. And then it will be as follows. So in the numerator we've got 2 raised by 2 and then raised by 2 again if we move this number 2 inside the parentheses. But if we raise a base to something and then raise it again, then we can multiply the exponents with rule number 3. So this number 2 and this number 2, we multiply it and get a 4. And then times 3 raised by 2. Now we have done this part here. In this part we move this exponent to the number 2 and to this power here. Multiply the 2 and the minus 3, getting minus 6. So 2 raised by minus 3 and then times 3 raised by minus 6. The whole bit squared, and in the denominator we've got the square root. But the square root, I can write it at once as raised by 1 over 3 instead. So I use rule number 7. So I write it like this. And in the numerator, I multiply the exponents, and the same in the denominator. So we got 2 raised by minus 6 divided by 3 raised by 9. And then we move these exponents into the base here. So 4 times minus 1 equals minus 4. So it will be 2 raised by minus 4, and then times 3 raised by minus 1. And in the next power we multiply this base here, or this exponent, with 2. So the exponent here will be 6, and this exponent will be 4. So 2 raised by 6 and 3 raised by 4. And the whole thing should be raised by the power of minus 1 over 2. And now we can, in the numerator, we can use rule number 1 and simplify all powers with the same base. So if we take the powers here with base 2, this one and this one, we can simplify this by adding the exponent. So exponent 4 and minus 3 equals, if we add them, we get a number 1. And I don't write this exponent because 2 raised by 1 equals 2. Exponent for 3, if we add the exponent 2 and minus 6, we get minus 4. So 3 raised by minus 4. And in the denominator, we can, in this bit here, we can use rule number 6 to get the exponent to move into the numerator and denominator in this part of the expression. And when we do it, we get 2 raised by minus 6 raised by 1/3, but we know that rule number 3 tells us that we can multiply the exponents with each other. And if we multiply minus 6 with 1 over 3, then we get minus 6 divided by 3, and then it equals minus 2. So I write 2 raised by minus 2 for this bit here, raised by 1 over 3, and then divided by 3 raised by 9, multiplied with 1 over 3, and it equals 3 raised by 3 if we multiply the exponents. So I write it like this. And then we multiply this power with the base 2 and this power with the base 2, add the exponent minus 4 and 6, and get the new exponent 2. So 2 raised by 2, and the new exponents for the power with base 3, minus 1, and this exponent here 4. If we add them, we get the exponent 3. So it will be 3 raised by 3. And of course, the numerator, we should square it. I almost forgotten this. And the whole thing should be raised by minus 1 over 2. And now in the numerator, we can move this exponent here inside the bases by rule number 5 here from right to left. And then it will be 2 raised by minus 1 over 2. No, 2 raised by 2. It is this exponent here we move inside. And times 3 raised by minus 4 and raised by 2. Then we multiply the exponents, rule number 3, and get the exponent minus 8. In the denominator, we can cancel 3 raised by 3 and 3 raised by 3, because one of them is a multiplication and the other one is a division, and they cancel each other out. And 2 raised by minus 2 and 2 raised by 2, if we multiply them and use rule number 1, we can add the exponent and get the exponent 0. So in the bottom we write 2 raised by 0. And the whole thing raised by minus 1 over 2. 2 raised by 0 in the bottom, it equals 1. So this bit we can cancel it out immediately. And now if we take the exponent here and move it inside the bases by rule number 5, then we got this 2 raised by, and we multiply the exponents. So 2 multiplied by minus 1 over 2, it equals minus 1. Okay? 2 over 2 equals 1, and if we have minus, it gets minus 1. And then 3 raised by minus 8 times minus 1/2. Minus times minus equals a positive number, and 8 times 1/2 equals 8/2, and then it equals 4. So we have this bit. And of course, when we have 2 raised by -1, if we use rule number 4, it is the same thing as move this power to the denominator instead if we change the sign in the exponent. So this is equal to 3 raised by 4 divided by 2, and we change the exponent to a positive number 1. And this can be rewritten as 3 times 3 times 3 times 3, 81 divided by 2. And this is the final answer to this expression, 81/2. If you like this video, please give me a thumbs up, and I hope that you try to do this calculation on your own also. I am Jonas, by the way, a Swedish math teacher. Please subscribe if you like my channel. Bye bye.